Major use case for blockchain technology is the use of decentralized finance, or DeFi. A key component of DeFi are cryptocurrencies, or ERC20 compliant tokens. Today, we're going to be going over how you can make your very own ERC20 compliant token from scratch, as well as using a pre-built Open Zeppelin library. My name's Anthony with the Blockchain Dojo, where we turn you into a blockchain ninja and a Solidity expert. If you learned something new, please like and subscribe. Let's get started. In today's tutorial, we're going to be going over how you can code your very own cryptocurrency, or ERC20 compliant token from scratch, as well as how to utilize the Open Zeppelin library. What we'll be going over is the main functions that make a token ERC compliant and how to actually implement them in your smart contract. The ERC20 standard is utilized across the entire blockchain. And essentially what this standard does is it provides standard use of functions that other developers and applications can hook into and utilize. By creating this standardized format, tokens can be utilized within third-party contracts such as Uniswap or PancakeSwap, as well as other decentralized applications for staking and things along those lines. Having a uniform standard allows you to swap these tokens out interchangeably, so that you can utilize different ERC20 tokens for different applications and protocols. What ERC is, or what it stands for, is the Ethereum Request for Comment, which is essentially an implemented standard or protocol in the Ethereum network. With that being said, going on to the ethereum.org and pulling up what the ERC20 standard involves, we have a few methods here that we need to implement, as well as a few events. We need to have a name, a symbol, the decimals, the total supply. We need to have a mapping for the balances of, so we can return this address. We need a function for transfer and transfer from, and approval and allowances, as well as we will need events for both the transfer and the approval. So getting started right into the nitty-gritty of this, the first thing we want to do with our ERC20 contract is we want to declare the license identifier as well as the pragma statement for the Solidity. Next, we want to declare the contract and the token. And then if we remember correctly, the first of the functions that we need to implement are the name, the symbol, the decimals, and total supply. What's cool with Solidity is when you declare a variable as public, Solidity automatically gives you the getter functions. So just by declaring string public name, we can do token.name as the function, and it will return the name without actually having us code a function getName function to return that Solidity also has that built in for the balances of and the allowances for mappings. So after we declare the necessary name, symbol, decimals, and total supply, we have a mapping of address to uint, and this is the balances of, or the balance tracker of, how much each wallet address currently holds of this specific token. Next, what we have is the mapping of the allowances. This allows a third-party contract or protocol to actually transfer and utilize tokens that somebody else owns. So here we have the address owner, then this would be the delegator of who you want to send the tokens to, and how much of those tokens that they can actually interact and move with. Next, we have two events. We have our transfer event and our approval event. These are emitted when we, of course, obviously transfer tokens, as well as when we increase approval and allowances. Next, we have our constructor. Now, our constructor takes in the name, the symbol, total supply. And what this does is it sets the name variable to storage, the symbol in storage, and the total supply times the decimals. Now, for those of you who do not know, in Ethereum, or with Ethereum and other tokens, one token isn't represented like this. It's represented with 18 zeros afterwards. So this would actually represent one token. So what we do is we multiply the total supply times 10 to the power of the decimals. That way we can get the full token amount. Next, what we do, since this is a fixed supply contract, we're going to transfer the entire balance of the total supply to the balances of the message.sender, which is essentially the deployer. Next, we're going to go over the transfer function, which takes in an address of who you're sending it to, and then the value, and returns a Boolean for success. Now with this function, what we do is we require that the balances of the message.sender to be greater than or equal to greater than or equal to the value being sent. And then we call this internal transfer function. This internal transfer function is a helper function, which is going to be used for the transfer and the transfer from. What this does is it takes in an address from and an address to and a uint value, and then it performs the logic of updating the storage variables and the mappings to include the updated values. Next, we have our approve function. Our approve function is what changes the mapping of the allowances to allow third parties and other smart contracts and protocols to actually interact and use your tokens for you. So it's essentially like a delegated approval. And then finally, we have the transfer from. The transfer from function is similar to the transfer function, but this is what's actually utilized by the third-party functions or third-party protocols. So essentially what this means is after the approve function is called and you say you allot Uniswap to transfer 10 tokens, this transfer from function would then be invoked, allowing Uniswap to actually interact with your 10 tokens to transfer them to either the protocol themselves or another person. And as you can see, the transfer from also includes this helper internal transfer function. So that was a brief overview of the ERC20 contract from scratch. You're asking if there are a lot of contracts that already implement this standard. There has to be an easier way to write this, so we don't have to write this out every time. And if you are thinking that, you are correct. Next, we're going to be going over the Open Zeppelin implementation of the ERC20 contract and how much easier it is to actually write one of these tokens. Let's get started. With this smart contract, you see that we had to code out every single one of these functions by hand, which seems a bit repetitive. We're going to come over here, and this is all the code needed to write in the Open Zeppelin ERC20 contract implementation. So with this, it's pretty simple. Now, a few of these imports you can actually get away with, and then you don't actually need. Technically, the only one that we do actually need is the ERC20 implementation here. But what we're doing is we're implementing the ERC20 burnable, ownable, and access control. That way that we can mint and burn tokens should we need to. Now with this, as you can see, there's a whole lot of code written here. And that's because most of those ERC20 standards are actually implemented here in this contract. As you can see, the symbols, the decimals, the total supply, balance of, transfer, and all those contracts are actually rewritten or pre-written so that we just have to implement them and inherit them into our contract. Now with this, I did include a few other options. So with this, we have the ERC20 burnable, which allows us to burn tokens, the ownable, which allows us to set the owner variable as message.sender, and access control, which allows us to set up additional access control roles for other users to interact with our contracts and have authority or access to do so. Similar to the other contract, you see we have the constructor here passing in the token name and symbol. But what's different is with this, we have a mint function. So instead, in the previous contract, we had a fixed set amount supply that we just assigned to the message.sender. With this option, we're going to be minting on a by need basis from the managers. So the entire balance isn't sent directly to the deployer at first, but when we need to mint new tokens, we can. Also, what's pretty cool is with this ERC20 burnable contract, we are able to implement a burn function where we're able to burn tokens should the supply get too great. Thank you to everyone who stayed and watched to the end. That was the 2 ways to create an ERC20 compliant token, writing it from scratch and implementing the ERC20 Open Zeppelin library. My name is Anthony, once again with the Blockchain Dojo. I hope you guys learned something new. Please like and subscribe for more content and stay tuned for the next one.